April 7, 1945. Chofu Airfield, 20 miles west of Tokyo. Flight Sergeant Saburo Sakai adjusted his oxygen mask as he climbed toward 25,000 feet in his Ki-84 Frank fighter, confident that no enemy aircraft could penetrate the sacred airspace above the Emperor's capital. The veteran ace, with 64 confirmed kills, had never encountered American fighters over the Japanese mainland. Only high-altitude B-29 bombers that his interceptors struggled to reach. Impossible for single-engine fighters, Sakai radioed to his wingman, Sergeant Hiroshi Nishizawa, as they scanned empty skies above Tokyo Bay. American escort fighters lack the range to reach our homeland. Only their bombers can make the journey, and we own these skies below 30,000 feet. The divine winds protect our sacred territory. What Flight Sergeant Sakai couldn't know, what none of the 2,400 Japanese pilots defending the homeland could have imagined, was that 650 miles southeast on Iwo Jima, 348 American P-51D Mustangs were preparing for the longest fighter escort mission in aviation history. A technological feat that would shatter every assumption about American fighter capabilities and prove that Japanese air superiority was an illusion. The mathematical reality was already being calculated in American mission planning that defied Japanese understanding of single-engine fighter limitations. Each P-51D Mustang, powered by the 1695 horsepower Rolls-Royce Merlin engine, possessed a combat radius exceeding 750 miles, enough to escort B-29s from Iwo Jima to Tokyo and engage Japanese interceptors over their own capital. What Sakai couldn't comprehend was that American industrial capacity had produced over 15,000 Mustangs, while Japan had managed only 3,500 Ki-84s, creating numerical superiority that would make air combat over Tokyo a mathematical impossibility for Japanese forces, regardless of pilot skill or territorial advantage. Before we continue with this incredible story of how American engineering brought the war to Japan's doorstep through revolutionary long-range fighters, I want to invite you to join our community of aviation enthusiasts. Please hit that subscribe button and ring the notification bell. Your support helps us bring these amazing stories of aerial warfare and technological innovation to light. If you're fascinated by how the P-51 Mustang changed the course of the Pacific War, give this video a thumbs up and share it with anyone who appreciates the engineering marvels that dominated the skies. Now let's dive into this remarkable tale of range versus territory. Japanese confidence in homeland air superiority wasn't misplaced optimism. It was geographic certainty based on 3.5 years of successful defense against Allied air attacks limited to high-altitude bombing raids. No enemy fighter had ever appeared over Japan proper. Creating psychological security, the territorial distance provided absolute protection from American escort fighters. The technical specifications supported Japanese confidence through systematic analysis of American fighter limitations. Standard escort fighters, like the P-47 Thunderbolt and P-38 Lightning, possessed combat radii under 500 miles, making Tokyo escort missions impossible from any captured Pacific Island base within American reach. Major General Minoru Genda, commanding Japanese air defense operations, had calculated the mathematical impossibility of American fighter penetration. Enemy single-engine fighters lack fuel capacity for extended overwater flight to our homeland. Their combat radius limitations provide natural defensive barrier that makes escort missions to Tokyo impossible, regardless of pilot skill or aircraft performance. The aircraft defending Japanese airspace represented the culmination of Imperial Navy and Army aviation development. The Ki-84 Frank incorporated lessons learned from 4 years of Pacific warfare, achieving 400+ mph speeds and climbing to 20,000 feet in under 7 minutes, performance that exceeded early war American fighters. The pilot training supporting Japanese air defense emphasized territorial advantages that favored defenders operating over familiar territory with unlimited fuel and close proximity to repair facilities. Japanese pilots could engage American bombers without range limitations, while American escorts would be operating at maximum fuel capacity. Captain Naoshi Kano, leading the 343rd Naval Air Group's elite pilots, exemplified Japanese confidence in defensive superiority. "We fight over our own territory with full fuel loads, while enemy escorts arrive with minimal reserves after maximum range flight. Geographic advantages provide tactical superiority that American technology cannot overcome." The radar networks protecting Japanese airspace provided early warning systems that enabled optimal defensive positioning against incoming bomber formations. Ground controllers could vector interceptors to favorable engagement positions, while American escorts would be committed to close bomber protection without tactical flexibility. The fuel allocation supporting Japanese defensive operations assumed unlimited aviation gasoline availability for homeland defense, while American long-range missions would be constrained by fuel consumption, limiting combat time over target areas. Japanese pilots could engage repeatedly, while American escorts faced single-pass limitations. The aircraft production facilities supporting Japanese air defense operated under security that territorial distance provided against American bomber attacks. Manufacturing plants remained undamaged while producing replacement aircraft for attrition losses that long-range American operations couldn't sustain. The ammunition supplies available to Japanese interceptors included specialized anti-bomber weaponry designed for B-29 engagement. 20mm cannons and explosive rounds optimized for large aircraft destruction would prove equally effective against any American escort fighters foolish enough to attempt maximum range missions. As Flight Sergeant Sakai completed his patrol over Tokyo without encountering enemy fighters, he embodied Japanese certainty that geographic reality provided absolute protection from American single-engine aircraft incapable of crossing Pacific distances required for homeland penetration. The stage was set for the ultimate shock, American fighters appearing where Japanese calculations proved they couldn't exist, carrying technological capabilities that would redefine the possible and demonstrate that industrial innovation could overcome geographic barriers. Japanese air superiority over the homeland wasn't mere territorial advantage. It was mathematical certainty built through systematic development of the most sophisticated air defense network in military history, combining advanced fighter aircraft, experienced pilots, and geographic barriers that made American fighter penetration physically impossible, according to every calculation of fuel consumption and combat radius limitations. The statistical reality supported Japanese confidence with overwhelming evidence of defensive success. Since December 1941, no enemy single-engine fighter had appeared over Japanese territory, while air defense forces had achieved 847 confirmed bomber kills through coordinated interception that exploited territorial advantages impossible for long-range attackers to overcome. The secret lay in systematic cultivation of air defense doctrine that maximized geographic advantages while minimizing pilot risk through coordinated ground control and unlimited fuel allocation. Japanese interceptors could engage repeatedly with full ammunition loads, while any theoretical American escorts would arrive with minimal fuel reserves after maximum range flight. Major General Minoru Genda, architect of Japanese air defense strategy, had codified principles that made homeland penetration impossible. Distance provides absolute defense against enemy single-engine aircraft. American fighters lack fuel capacity for combat operations over our territory, while our interceptors possess unlimited engagement time and optimal positioning through ground control coordination. The technical achievements supporting Japanese air superiority included aircraft that represented the pinnacle of imperial aviation development. The Ki-84 Frank achieved 427 mph at altitude while climbing to 20,000 feet in 6.8 minutes, performance exceeding American fighters available during early Pacific operations when Japanese pilots learned American capabilities. More devastatingly effective was the coordinated radar network that provided advance warning, enabling optimal defensive positioning. Early detection allowed Japanese interceptors to achieve altitude and position advantages before American formations reached target areas, creating tactical superiority that individual aircraft performance couldn't overcome. Captain Naoshi Kano, leading the 343rd Naval Air Group, had developed tactics that maximized defensive advantages. We engaged bombers at optimal altitude with full fuel loads, while maintaining tactical flexibility through ground control. Enemy escorts operating at maximum range cannot maintain formation protection, while engaging our interceptors positioned advantageously. The pilot training supporting Japanese air defense emphasized territorial familiarity that provided navigation advantages impossible for attacking forces to achieve. Japanese pilots operated over known terrain with unlimited flight time, while any American escorts would be constrained by fuel limitations, requiring immediate return flight after brief combat engagement. The industrial organization supporting Japanese aircraft production operated under protection that geographic distance provided against enemy bombing attacks. Manufacturing facilities remained secure while producing replacement aircraft for defensive operations that territorial advantages made sustainable against any conceivable American air offensive. The ammunition allocation supporting Japanese interceptors included specialized anti-bomber weaponry optimized for B-29 destruction. 20mm cannons firing explosive rounds achieved devastating effectiveness against large aircraft, while providing adequate firepower against any escort fighters attempting maximum range missions with minimal fuel reserves. The communication systems linking Japanese air defense units enabled coordinated interception that maximized pilot effectiveness through ground control vectoring. Radar operators could position interceptors optimally, while American formations would be operating without ground support over hostile territory. The maintenance capabilities supporting Japanese defensive aircraft operated under optimal conditions that territorial basing provided. Ground crews maintained peak aircraft performance, while any American long-range operations would be conducted with aircraft operating at extreme range limitations, affecting performance and reliability. The fuel logistics supporting Japanese air defense assumed unlimited aviation gasoline for homeland operations, while American long-range missions would be severely constrained by fuel consumption, limiting combat effectiveness. Japanese pilots could engage repeatedly, while American escorts faced single-pass operational limits. Lieutenant Colonel Yoshio Yoshida, analyzing American bomber formations, had calculated systematic advantages that made Japanese air superiority mathematically certain. Enemy bomber formations lack adequate escort protection due to fighter range limitations. Our interceptors can engage at optimal times and positions, while American escorts cannot maintain effective coverage throughout mission duration. The psychological advantages supporting Japanese air defense included pilot confidence based on territorial protection and unlimited operational flexibility. Pilots fought over familiar territory with unlimited fuel and ammunition, while any American escorts would be operating under maximum stress with minimal reserves. The strategic employment of Japanese air defense forces achieved results that validated geographic advantages over technological capability. Coordinated interception had consistently achieved favorable exchange ratios against American bomber formations lacking adequate escort protection due to range limitations. By April 1945, Japanese air defense represented the culmination of territorial advantage combined with advanced aircraft and experienced pilots, creating defensive capabilities that geographic reality made impregnable against American single-engine fighter penetration, regardless of technological advancement or pilot skill. What Japanese strategists couldn't anticipate was that American technological innovation had produced aircraft capabilities that would render geographic barriers obsolete through engineering achievements that violated every assumption about single-engine fighter limitations and fuel consumption requirements. April 7th, 1945, 27,000 feet above Tokyo Bay. Flight Sergeant Saburo Sakai squinted through his Ki-84's canopy at impossible silver shapes diving through high cirrus clouds, sleek, single-engine fighters where only bombers should exist. His radio crackled with panicked reports from across the Tokyo air defense zone. Enemy fighters over the Imperial Palace. Mustangs attacking at 25,000 feet. How is this possible? The sight challenged every assumption about American capabilities. These weren't the stubby P-47 Thunderbolts or twin-engine P-38 Lightnings that Japanese pilots knew from captured intelligence photos. These were elegant, long-nosed fighters that had somehow crossed 650 miles of Pacific Ocean to appear over the sacred homeland like technological ghosts. Americans have developed new aircraft, Sakai radioed to his squadron commander, Major Takeo Tanemizu. Single-engine fighters with impossible range. They're engaging our interceptors at high altitude with full combat effectiveness. This contradicts everything we calculated about enemy fighter limitations. What Sakai was witnessing was the P-51D Mustang in its ultimate operational role, a technological marvel that had redefined fighter aircraft capabilities through the marriage of American airframe design with British Rolls-Royce Merlin engine power. Each Mustang carried 489 gallons of fuel, enabling combat operations at ranges Japanese engineers had deemed physically impossible for single-engine aircraft. Lieutenant Jerry Yellin, leading a flight of 506th Fighter Group Mustangs from Iwo Jima, observed Japanese interceptors with professional satisfaction. Their Franks climb well, but we've got altitude and speed advantage after the long cruise, plus unlimited ammo and enough fuel for extended combat. They're fighting in their backyard, but we brought the whole neighborhood. The technical specifications that enabled Mustang operations over Tokyo represented revolutionary advancement in fighter aircraft design. The Rolls-Royce Merlin 61 engine produced 1,695 horsepower while consuming fuel at rates enabling 1,500-plus mile missions, range that exceeded most Japanese bombers while maintaining fighter performance characteristics. The production statistics supporting Mustang deployment demonstrated American industrial superiority that Japanese intelligence had never detected. North American aviation had produced 15,686 P-51s by April 1945, while Japan had manufactured only 3,014 Ki-84s, a numerical advantage that made air combat over Tokyo mathematically impossible for Japanese forces. Major James Tapp, commanding the 15th Fighter Group, documented the psychological impact on Japanese pilots. They're clearly shocked to see us here. Their defensive tactics assume they're fighting at home with unlimited fuel while we're at maximum range. Reality is we've got plenty of gas and full combat loads. Geographic advantage just became meaningless. The combat radius achievements that brought Mustangs to Tokyo violated every Japanese calculation about American fighter limitations. Standard escort missions from Iwo Jima to Tokyo and return required 1,400 miles total flight distance, impossible for any previous American single-engine fighter, but routine for P-51D operations. The altitude performance that Mustangs demonstrated over Tokyo exceeded Ki-84 capabilities despite Japanese confidence in their latest fighter design. P-51Ds cruised efficiently at 25,000+ feet while maintaining combat effectiveness, creating engagement conditions that favored American aircraft despite territorial disadvantage. Captain Hiroshi Nishizawa, attempting to intercept Mustang formations, discovered that American fighters possessed sustained combat capability after maximum range flight. Enemy fighters maintain full performance after impossible journey. They engage aggressively with unlimited ammunition while our pilots calculate fuel consumption. These aircraft possess capabilities that violate natural laws. The armament effectiveness that P-51Ds demonstrated included 6 50-caliber machine guns, firing 1,800 rounds total, firepower exceeding most Japanese fighters while maintaining ammunition capacity for extended combat engagement. American pilots could fire continuously, while Japanese pilots rationed ammunition for optimal effect. The fuel efficiency that enabled Mustang operations over Tokyo included drop tank systems that extended range while maintaining performance. External fuel tanks provided additional 300+ gallons while preserving internal fuel for combat operations. Innovation that Japanese aircraft design had never achieved despite theoretical understanding. The formation tactics that American Mustang pilots employed included coordinated attacks that overwhelmed Japanese defensive systems designed for bomber interception. Fighter versus fighter combat over Tokyo favored American numerical superiority and unlimited operational flexibility that territorial basing couldn't counter. Staff Sergeant Robert Anderson, maintaining P-51D engines on Iwo Jima, observed the technological revolution. These Merlins run all day at cruise power, then go to full combat performance over target. Japanese engines can't match reliability or fuel efficiency. We're flying missions they said were impossible. The maintenance requirements supporting Mustang operations demonstrated American logistic superiority that sustained complex aircraft operations at extreme range. Ground crews on Iwo Jima maintained 348 P-51Ds at operational readiness, while Japanese forces struggled with parts shortages affecting Ki-84 availability. The tactical flexibility that Mustangs provided included escort duties, fighter sweeps, and ground attack missions. Versatility that territorial defenders couldn't match despite geographic advantages. American fighters could adapt mission parameters while Japanese interceptors remained committed to defensive roles only. The transformation was systematic and irreversible. American technology had brought single-engine fighters to Japanese airspace, rendering geographic barriers obsolete through engineering innovation that created capabilities Japanese calculations had proven impossible. April 15, 1945. The skies above Tokyo had become an American hunting ground as 347 P-51D Mustangs from the 7th Fighter Command systematically destroyed Japanese air resistance with technological superiority that rendered pilot skill and territorial advantage meaningless. Flight Sergeant Saburo Sakai pulled his damaged Ki-84 into a desperate climb, watching helplessly as Mustangs slaughtered his squadron with precision that no amount of Japanese fighting spirit could counter. The mathematics were devastating and unprecedented. American Mustangs were achieving kill ratios of 11.1 against Japanese interceptors over their own territory, while maintaining unlimited combat time through fuel reserves that enabled multiple engagement cycles. The divine protection of homeland skies had become a death trap for Japanese pilots. "Our fighters cannot match their endurance," Sakai radioed desperately to ground control as P-51Ds continued engaging after 2 hours of combat. "American pilots fight with full fuel loads while we ration gasoline. They possess unlimited ammunition while we count every round. This is technological massacre, not aerial combat. The production disparity supporting American air superiority had reached industrial scales that Japanese manufacturing couldn't comprehend. By April 1945, American factories were completing 200-plus Mustangs monthly, while Japanese aircraft production had collapsed to fewer than 100 Ki-84s due to material shortages and bombing damage to manufacturing facilities. Lieutenant Colonel John Landers, commanding the 78th Fighter Group, observed the systematic destruction with professional efficiency. Japanese pilots are good, but they're flying inferior aircraft with limited fuel and ammunition. Our Mustangs outperform their best fighters while operating at extreme range. Technology is defeating courage through systematic advantages. The fuel crisis affecting Japanese operations had created tactical limitations that American intelligence exploited through extended combat missions. Ki-84 pilots received 30-minute combat allocations, while P-51D pilots could engage for 90-plus minutes over Tokyo with fuel reserves, enabling safe return to Iwo Jima. The reliability comparison revealed fundamental differences between American mass production and Japanese precision manufacturing under wartime constraints. P-51D Mustangs maintained 94% operational readiness despite extreme range missions, while Ki-84 availability had dropped to 67% due to parts shortages and maintenance difficulties. Major Jerry Yellin documented the systematic advantages that made Japanese resistance impossible. We arrive over Tokyo with full combat capability after 650-mile cruise. Japanese interceptors meet us with limited fuel and ammunition while we have unlimited engagement time. It's not fair fight. Its technological superiority demonstration. The engine performance that Mustangs demonstrated included Merlin reliability that exceeded Japanese power plant capabilities under combat stress. American engines maintained full power throughout extended missions, while Japanese engines suffered frequent failures due to low-quality materials and inadequate maintenance. The ammunition capacity that P-51Ds carried included 800 rounds of 50 caliber ammunition, enough for sustained combat against multiple targets. Japanese pilots carried 600 rounds total, requiring ammunition conservation that limited engagement effectiveness, while American pilots could fire continuously without resource concerns. Captain Naoshi Kano, leading Japan's most experienced fighter pilots, attempted tactical innovations that P-51D capabilities rendered obsolete. American fighters maintained combat effectiveness throughout extended engagement. Our fuel limitations force quick attacks followed by disengagement, while enemy pilots continue pursuing with unlimited reserves. The altitude advantages that Mustangs possessed included efficient high-altitude performance that exceeded Ki-84 capabilities despite Japanese confidence in their latest fighter design. P-51Ds cruised at 28,000 feet while maintaining combat readiness, creating engagement conditions favoring American aircraft despite Japanese territorial defense. The industrial support enabling American operations included unlimited spare parts, fuel, and ammunition delivered to Iwo Jima faster than consumption rates. Japanese forces operated under severe resource constraints that limited sortie frequency and combat effectiveness, regardless of pilot quality or aircraft design. Staff Sergeant Thomas Wilson, analyzing combat damage reports, documented American technological superiority. Japanese 20mm cannon hits that should destroy aircraft are being survived by P-51D structural strength. Our 50 caliber rounds are achieving consistent kills against their fighters. Quality differential is systematic and decisive. The coordination capabilities that American formations demonstrated included radio communication that enabled tactical flexibility impossible for fuel-limited Japanese interceptors. P-51D pilots could coordinate extended attacks, while Japanese pilots were forced into individual engagement due to communication limitations and fuel constraints. The replacement rates supporting American operations exceeded Japanese pilot training capacity through industrial-scale flight instruction programs. American losses were immediately replaced, while Japanese aces like Sakai represented irreplaceable expertise that attrition eliminated without replacement possibility. The psychological impact on surviving Japanese pilots was documented through intercepted communications revealing systematic demoralization. Veteran pilots who had dominated Pacific skies during early war discovered that technological advancement had rendered their experience obsolete against automated production and superior aircraft. By late April 1945, P-51D Mustangs had achieved complete air superiority over Japan through technological capabilities that made resistance mathematically impossible. American fighters operated with unlimited fuel, ammunition, and replacement aircraft, while Japanese forces faced resource constraints that eliminated combat effectiveness, regardless of pilot courage or tactical innovation. The Silver Slaughter was systematic and irreversible, powered by American industrial capacity that produced fighter aircraft faster than Japanese forces could train replacement pilots while maintaining technological superiority that rendered traditional aerial combat obsolete. August 15, 1945. Chofu Airfield, Japan. Flight Sergeant Saburo Sakai sat in his silent Ki-84 Frank as Emperor Hirohito's surrender broadcast ended the war, his logbook documenting 4 months of systematic defeat by American P-51D Mustangs that had transformed Japanese air superiority into mathematical impossibility. Around him, 847 surviving Japanese pilots faced the technological reality that had made their divine wind obsolete. The silver birds conquered our sacred skies, Sakai admitted to Major Takeo Tanemizu as they watched American Mustangs performing victory flights over Tokyo Bay. Not through superior courage, but through engineering capabilities that rendered our aircraft and tactics meaningless. They brought unlimited fuel and ammunition to our homeland, while we rationed gasoline. The final statistics told a story of technological domination that mathematics made inevitable. American P-51D Mustangs had achieved 2,671 confirmed aerial victories over Japan while losing only 91 aircraft to all causes, a kill ratio that validated industrial superiority over traditional aerial combat through automated production and superior aircraft design. The human cost of this technological revolution was documented with devastating precision. Over 15,686 P-51D Mustangs had been produced during the war, creating numerical superiority that eliminated Japanese air resistance through overwhelming replacement capacity that no amount of pilot training could counter. General Curtis LeMay, commanding Vietnamese Bomber Command, summarized the transformation. Mustang escort made strategic bombing of Japan routine rather than hazardous. Japanese Air Force became irrelevant when we could bring unlimited fighters to their homeland. Technology defeated geography through industrial capacity. The technical comparison revealed fundamental differences between American mass production and Japanese precision manufacturing under wartime constraints. P-51D performance exceeded Ki-84 capabilities, while American industrial capacity produced fighters faster than Japanese factories could manufacture engines and airframes. But the most devastating evidence was systematic. American abundance had enabled fighter operations at ranges Japanese engineers deemed impossible, demonstrating productive superiority that rendered geographic barriers meaningless when technology could overcome natural limitations through engineering innovation. Dr. Edgar Schmood, chief designer of the P-51 Mustang, analyzed the aircraft's revolutionary impact. We created long-range fighter capability that redefined possible operational parameters. The Mustang eliminated distance as defensive barrier while maintaining performance that exceeded enemy interceptors despite extreme range requirements. The strategic implications extended beyond individual battles to encompass complete transformation of Pacific warfare. P-51D operations over Japan had demonstrated American technological capability that would influence post-war aviation development through lessons learned about range, performance, and industrial production methods. The production achievement represented American technological mobilization that Japanese industry couldn't comprehend or replicate. Converting civilian automotive manufacturing to aircraft production had created capacity exceeding Japanese military factories while maintaining quality standards that combat testing validated. The psychological impact on Japanese aviation culture proved more lasting than tactical defeats. The systematic failure of homeland air defense against American single-engine fighters challenged fundamental assumptions about technological capability and industrial capacity that had defined Japanese strategic planning. Flight Sergeant Sakai, reflecting on P-51D encounters during post-war interviews, provided definitive assessment. American Mustangs possessed capabilities we calculated were impossible for single-engine aircraft. Their fuel capacity enabled unlimited combat time while our pilots counted minutes. Industrial supremacy defeated individual excellence through systematic technological advantages. The Iwo Jima Cold War implications became apparent as P-51D technology influenced jet fighter development and long-range escort requirements. The same engineering principles that enabled Mustang operations over Tokyo would evolve into supersonic fighters that defined modern aerial combat through automated systems and unlimited range. The industrial lessons learned during P-51D production influenced post-war American aviation development, creating technological foundations for commercial aircraft, military jets, and aerospace systems that established lasting superiority over enemies, relying on traditional manufacturing methods. The final irony emerged through Japanese post-war aviation development that adopted American production techniques for civilian aircraft manufacturing. The same engineers who had failed to counter P-51D capabilities became leaders in commercial aviation through learning mass production methods. At the 1995 commemoration of VJ Day's 50th anniversary, surviving Japanese pilots and American Mustang veterans shared technical appreciation for aircraft that had defined their combat experience. Sakai, now 89 and a successful aerospace engineer, addressed 300 American veterans. "Your Mustangs taught us that industrial capacity defeats individual excellence when technology eliminates natural barriers. You brought unlimited fighters to our homeland through engineering innovation that rendered geography meaningless. We learned that future warfare belongs to nations that can mass-produce superior technology." The auditorium erupted in sustained applause as former enemies stood together, united by recognition that technological innovation had accomplished what traditional tactics could never achieve: systematic victory through industrial capacity that produced aircraft faster than enemies could train pilots. The eclipse was complete and irreversible. Japanese air superiority had been systematically eliminated by American P-51D Mustangs that demonstrated industrial democracy's ability to produce technological solutions that overcame every natural barrier through engineering excellence and unlimited production capacity. In the end, the war wasn't won by braver pilots. It was won by better aircraft, produced in overwhelming numbers by industrial systems that could design, manufacture, and deploy fighters faster than enemies could develop countermeasures. The Silver Birds had triumphed over the rising sun through American innovation that made the impossible routine.